Everyone. Let's solve Leetcode medium problem named as subset. So in this given problem, we have given an integer array nums, and we need to find all the subsets. So if you see the subset for this given input 1, 2, 3, we have got total 8 subset, that is 2 to the power 3. So for each number, either we can include this into output or not include it. That's why for each number we have two options, either include or not include. So for any number, we have two options, and that's why for this given input 3, we have the output total as 8. So let's see what could be the way to solve it. So if we quickly analyze this input and output, so very first is the empty subset. So you can put this into at end of the your program. But let's say the moment we are finding like iterating on one by one on the input numbers, we find the one. We have pushed the very first subset would be one if you are at this index 0, 1. When we move to the 2, we'll be pushing this again to the same what we did the previous number. And also we'll see whatever the previous subsets we do have, excluding the empty subset. So we had 1, then we will make a subset using 1 as well. So 1, 2, we can push here as well. When we move to the 3, we'll be pushing this 3 again into this output. And then what we will see, what is the previous subset we have? So previous subset we have these 1, 2, and 1, 2. So with 1, we can make 1, 3. With 2, we can make 2, 3, and with 1, 2, we can make 1, 2, 3. And that's why you can see our total number of output, including empty subset, is 8. So that could be the one of the way to solve it. The better approach would be using, backtracking algorithm. So let's see how with backtracking, we can solve it. So with backtracking, what is the option we do have here? If this is a given one input 1, 2, 3, so what we can do, we can start from the very first number, which is I index as a 0. And when we are here, for each number, as we know, we have an option, either we can include it, this number, or we can exclude it. So if you're going to include this number in our subset, so that is like first we need to know the currently at which index we are there and what could be our subset when we are there. So for given input, let's say if you're at the index 0, if it's a 0, which is number 1, so either I can include this one or I can exclude it. When we are going to include it, our subset will have this one here. If you're excluding it, the subset would be empty. And then we're just going to increase the I by +1. So now our I will point to the 2. Similarly, at this place again, we will have an option to either include or exclude. If we're going to include, our subset will have, since previously we had 1 and we're including 2, so it will be 1, 2, and we're going to increase our index I by +1. And here, since we're going to exclude the 2, it will have only 1. And at the left hand side, since this was empty, we are going to include 2, so the input would be 2. If you're going to exclude, that would be again empty here. So if you analyze what we are doing at each place, right, either we are including it, so we can include a number, include a number, and then increase the index and call the same function again, right? So like we can have a defense function, just call the same function again. So that is the one of the operation we are doing. Otherwise, what we are doing, if we are at any particular index, we are going to exclude it, exclude the number, and then again increase the index and call the same function again one by one, right? That's what we are doing. So at any place, either we are including it or excluding it in our subset, and then increasing the index by +1, and at increasing the index by +1, and at the same place again, we are calling the same defense function, which is basically means either include or exclude, and then increase the index by +1. And what will happen if you're at the index 3? So we will be getting, at the similar place, if we are at the 3, we can get 1, 2, 3 if you're including. If you're not including, we'll have the 1, 2. Here we'll have 1, 3, 1, 2, 3, 2, 3, and at the end we'll have empty. So this is total subset is 8, which is 2 to the power 3, you can say. Now, when we are at here, this index will go out of bound, right? It will go whatever the input array we have. This will go out of the bound. So once this is like we have covered all the input, whatever the input we have, right? We have covered everything. Then we know that we have found the solution. So our solution is at the end of the tree, which we can say at the end of the index. So when I is equals to the length, then push all the subset into the output that we can do. So that is the condition you can say pretty much. So the base condition it the moment we reach like we have traversed everything into the given input, then we know that we have found our subset. Let's push into this our output or whatever the output we have, push it there. Otherwise, perform the operation, increase the number, like include the number or exclude the number, increase the index and call the refresh. So that would be the pretty similar thing. Let's quickly solve the problem as well. What we are trying to say. So we can initialize one output value array where we are going to push all the data, and we just need one subset where we are going to include our the items. Okay, now let's call one of the DFS function which basically needs to know the index, like at which particular index we are there, and we'll be just expecting it will push all the data into the output. So that's our expectation, that this DFS function will push all the correct data in output, which we can just return it. Now let's write the DFS function now. So this is like taking an index as an input, like at which particular index we are. So the base condition or return condition is what? When the index is equals to this length of the given nums array, right? Then we know that we have found all the subsets. So if index is greater than or equals to nums.length, then we know that our current subset, we have found a subset which we need to push into the output, right? So the way to do it, output dot push subset. But in JavaScript, this array like can be modified later. So instead of pushing directly the same thing, let's make it a clone of that. So let's temp is equals to because it's passed by reference. So instead of pushing direct the same, like instead of pushing the same thing, so that in future it doesn't get altered, let's make a clone of that. So here we are just making a clone of the input and then pushing this temporary array because it's passed by reference, right? So that's the thing, and then we can just break the recursion. That's the kind of the pretty much base condition. After this, when we are done, then we just need to either include or exclude it. To include basically means in our subset, just push the current number, whatever the index we are. So now we have included it. So this part we have done, if you see, like we have included the current number, this one. Sorry, yeah. So this part we have done currently, we are good with this. Like we have included a number, then we have also done this part. Okay. And now increase the index and call the DFS function again. So in DFS, we can call index plus one. So that's the pretty much like we have covered the left-hand side of the tree, what we have to do. Now to exclude a number from the subset, basically means whatever the data we have pushed into the subset, let's remove that. Or so that, we can just, we are not including it. So if you remove that current number, that basically means we have not pushed the data into the subset. So previously we pushed it, now we have just popped it. And then again go and call the DFS function with index plus one. Like, hold on a second here. Yeah. Yeah. So exclude the number, increase the index and call the DFS. That's what we just did here, right? So pretty much we have covered everything. Let's try to run this. Nums of I is not defined. Here it should be index. Now let's run this. Yeah, and we can just submit it. Yep. So it's got accepted. Thanks.